Hello friends and welcome at my channel. I'm still in love with L'Hopital and gonna do some more examples tonight. So let's see. We have a limit on x towards infinity, and then we're dealing with x to the power of n times e to the power of minus x, and we are considering a positive value of n. So I explained a little bit in the previous example that e is stronger than any polynomial, and here we just have to rewrite it and apply it immediately. So we have x to the power of n divided by e to the power of x. Now we have infinity over infinity again. Would be different if n could become a negative value, then it would be also in the denominator, and then the result would be easily 0. But n is positive, so let's apply L'Hopital's rule, and as you can see, each time we are going to apply L'Hopital's rule, the exponent gonna decrease, and in the denominator nothing is happening. So on the long run, the numerator at some point after applying L'Hopital's rule for n times, we are going to end up at the situation where we have n factorial times, well, just n factorial itself. Should I do it for? Well, you know what? The point is, it doesn't matter whether I have to do it n times or n plus 1 times. At some point, x is for sure disappearing, and in the denominator, nothing is happening. And now it's clear. N is a constant value. Well, some positive values could be huge, like 1000 factorial. It's a huge number, for sure. But e to the power of x is boundless. So it doesn't matter how big n factorial is going to become, e to the power of x is going to be way bigger. So the outcome is 0. Let's move on. Limit x towards infinity of x times sine of a to the power of x, a divided by x. Well, if we see it, if we look at this for the first time, well, x is increasing and a is some value. A divided by a huge number is decreasing, so it's running towards 0. It's not clear whether it's coming from the right hand side or from the left hand side because of the sign, so it could be plus or minus infinity. So maybe this limit does not exist at all. This is question number 1, or observation number 1. Question number 2 right here would be, can we somehow apply L'Hopital's rule? Not now, but what about sine? Well, a divided by x is running towards 0, so sine is running towards 0 as well. X is running towards infinity, not so nice, but if we rewrite it, and this is, well, you can call it a trick, but actually a tool, I would say. We keep sine of a divided by x in the numerator the way it is, and now we rewrite it as division by 1 divided by x means multiplication times its reciprocal, so multiplication times x, which exactly the original question. So now we have the numerator running towards 0 and the denominator running towards 0 as well. So what's happening here? L'Hopital's rule? Yes, sir. Let's see. We have cosine of a divided by x. Now we have the inner function. It gives us minus 1 divided by x squared, right? Minus a, I would say, divided by x squared. Divided over, well, 1 divided by x is minus 1 divided by x squared. You see, we can perfectly cancel this. It just gives you a. So we can take it outside of the limit, x towards infinity still, and now we have a cosine of a divided over x. So now what's happening with x? X is still running towards infinity. Cosine of 0 is becoming 1, and the value would be just a. I would say not so obvious, right? Okay, and the third question would be a generalization of this problem. Let's see what's happening if we have x still running towards infinity. X to the power of n times the sine of a divided over x with n bigger than 0. What's happening here? Well, once again, we are rewriting it slightly different as sine of a divided by x as 1 divided by x to the power of n. Or if you wish, it's the same, maybe easier to derive now, x to the power of minus n here. So what is the first derivative we are going to get here? Once again, it's the cosine of a divided by x times minus a divided by x squared. It's not changing. Here we got some change. It's minus n times x to the power of minus n minus 1. Ooh. Let's rewrite it. So minus and minus is gone. I can take a outside of the limit, so it's still limit x towards infinity. A divided by n I can take, right? So we got a cosine of a divided by x, which is now just 1. And now we have x to the power of n plus 1. Is that correct? I had minus n. I'm decreasing, so I'm minus n coming up. It's getting 1 less, so minus n minus 1. Yeah, I think it's fine. So what are we getting here? Cosine is for sure positive at 1. So this is plus infinity, and a divided by n, well, if a is a positive value, let's say it is a positive value, then this is positive as well, and this is plus infinity, so that would be infinity. All right. If a is negative, okay, we got a negative value, but it won't change the behavior or the pace of the function. So basically, x to the power of n is way stronger, way faster towards infinity than the sine could approach 0. And let's once again compare it with the previous result, where we had, well, relatively same, at least makeup, I would say. So kind of the same function looks like this, the same case, but it's not, right? The outcome is only a, and well, the power of n is pretty strong, you know. Okay, guys, thanks for watching. See you in the next video. All the best. Goodbye.